In this tutorial, we are going to discuss about what is a linear graph and how is it different than a line graph, okay? The basic concept of construction is about the same in both graphs. So on the left hand side of the screen, I have my graph and the graph data as number 1. By the way, this is the same example we have discussed when we were learning about the line graph, okay? And we have data in years from 2009 to 2013, the production crops in metric ton, okay? So we have this plot here in which the time is on x-axis and the production quantity is on y-axis. And how we obtained this plot is simply by plotting the ordered pair of x and y on this Cartesian coordinate plane. And then we finally connected all of these points, okay? This is how you obtain a line graph. A linear graph works exactly in the same steps as we have done for the line graph. So the data we have is the time in hours, and we are recording how much distance is covered in kilometers for a car journey, okay? So we have 1 hour, we have covered 40 kilometers, 2 hours 80, and 3 hours 120, and so on, okay? Now what we do is we simply plot these points on x and y axis, and I define my x axis to be the time axis, okay, and the y axis becomes the distance covered. This is my y axis. Simple enough, right? And as we obtain these points, we plot them. The next point is, of course, connecting all of these data points, and we do it, and then what we obtain is a straight line, right? A straight line that goes from the very first point. Let's say this is my first point right here, and this is my last point, which is right here. So this straight line connects all the way from 1 to 5. And this is a major distinction between a line versus a linear graph. So let me just put these names here. So this is my line graph right here, and on the right hand side of the screen is my linear graph. So a line graph is a graph in which we are connecting all the different points with short line segments, correct? A linear graph is the one in which starting from the point 1 all the way to the point 5, it represents by one line. And you could possibly extend this as well. If you were to extrapolate this line, you could possibly do it this way and this way, right? So you could do this extrapolation or interpolation between those points as well. Also, what you can do with a linear graph is that each linear graph represents a linear function. So let me explain how that works. So I'll create some space here, and we'll say that this is a linear graph, okay? It's a graph number 2 on the screen. So we'll say that the distance, which is denoted as d, is equal to 40 times t, where t is in hours, okay? T is in hours. If you look at the data, what we see that when t was 1, we substitute in this function, it becomes d is equal to 40, which is exactly this point. When t is equal to 2, you substitute in this function, it becomes 80, which is this point. So you see that each data point on this table can be represented by this function, which is d is equal to 40 times t, right? And we know that such functions are linear functions, right? So a linear graph can be represented by a linear function. So these are the major distinctions between a line graph versus a linear graph. In a line graph, you may find it hard to find one linear function that represents all of those data points going up and down. So let us go and have a look at another example of distinction between the line graph and a linear graph. So here is our another example, graph number 3, in which the time, which is on x variable, is in years from 2013 all the way up to 2017, and then we have the cash flow, the dollar value, and it is on the y-axis. Okay, so these are my x and y-axis. That makes the Cartesian coordinate plane, and we plot this data. We find a graph in such line segments. Okay, so this graph is again a line graph because we have individual data points connected by short line segments, and the x-axis is a time horizon and the y-axis is the variable under study. Okay, and then we have graph number 4. On the right hand side of the screen, What we are doing is we are plotting a linear function. So let me put it here, linear function, and this function is y is equal to 2x plus 7, correct? And then we have x and y values. From this function, we create this data table. Oh, okay. And once we have our data table, we simply put them on x and y axis. From here, we simply plot these values and we obtain a line that connects all of these values. So this becomes a linear graph because we can obtain one straight line. And of course, we don't have to even look at the graph because we are starting with a linear function to begin with. A linear function will always produce a linear graph. Okay, so the key takeaway from today's discussion is the distinction between a line graph and a linear graph. The process of construction, all of these graphs is exactly the same. They both represent the time on x-axis and the variable under study on y-axis. A line graph will be the one that has short line segments, and a linear graph will be the one which will show the continuity of all those data points, and it will show one straight line. Okay, so with that, I will stop the discussion here and I will recommend my students to go practice more on the line and linear graph via our quiz modules.